Okay, wonderful. And our next presenter is Dr. Leslie Beck. Dr. Beck is the Extension Weed Specialist, also in the Department of Extension Plant Sciences at New Mexico State University. She received her BS in Horticulture and Landscape Management and her Master's in Agriculture from Tarleton State University, specializing in golf course and turf grass management. She received her PhD in Plant and Soil Science, specializing in turf grass management, and from Texas Tech University. Dr. Beck's primary extension responsibilities include progressive statewide educational programming in weed science, including annual and perennial weed management, identification, and herbicide application for all cropping systems, including agricultural commodities and turf and landscaping areas. Thank you.
Thank you. Can everybody hear me okay? Usually that's not a problem for me. Usually it's, I feel bad for the people in the front row, especially. So as mentioned, I am the Extension Weed Specialist for the state of New Mexico. I cover everything from residential to every agronomic crop grown in New Mexico. Probably easier to say what I don't cover, which is range and pasture land. But of course we have, things that we have to consider with trees in every one of those systems. And luckily for me, everyone has weeds, right? So even if part of your position is not to take care of weeds in general, like we're going to talk about today, I guarantee you probably still take care of weeds around your home, around your property, maybe your older parents' homes. Everybody has weeds, right? Job security, right? So here we're going to talk about some of the things that we consider with weed management. And so the way I kind of designed this presentation is sort of to address a lot of the questions that I get about weed management, and especially how it might impact trees, because of course that's the primary reason why we're here today. So I am going to start off with the big bang here. What is the one way that we can be successful with weeds? Is everybody ready for this? Get ready. That's right. Never. No, I'm just kidding. Yeah, that's right. A weed is just a plant that hasn't been defined as its purpose in life yet, except to annoy you, right? Has anybody ever heard the saying, the early bird catches the worm? Absolutely. So when we talk about weeds, and if I can figure out how to work this, the early bird catches the weed. That is the universal truth, regardless of the weed that you're dealing with, regardless of the cropping system that you're dealing with, as long as you can try to focus your management, regardless of the management practice you're trying to utilize, whether it's hand pulling, whether it's using herbicide or cursing at it. The younger it is, the more it's going to be impacted by what it is that you're trying to do. And there's a lot of reasons for that. It's a lot easier to pull out a taproot that's a couple of inches deep rather than 6 feet deep, right? What have young plants not developed yet? Everything. Seed, deep taproots, rhizomes, stolons, all of the things that coupled together make it just that much more difficult to control. The younger the weed, the easier it is to control. As a result, there are very specific timings and things that we need to know about each one of these weeds in order to be more successful with how we utilize our management. Work smarter, not harder, right? So when we think about weeds and the management decisions that we make, it's really important to consider the weed that you're targeting. What is it about a dandelion that we have to focus on as managers beyond saying, ooh, dandelion, and everybody's impressed with your ability to identify? I relate to that specifically. But what is it about a dandelion? Does it produce a lot of seed? Is it a perennial? Does it have a deep taproot system? All of these things we have to know. And therefore, it really is important to know if you're dealing with an annual or a perennial. In some cases, weeds might actually skirt both. Is it important to know the reasons for success? Absolutely. Are you targeting seed production? Are you targeting deep taproot systems, rhizomes, stolons? Are you targeting all of them? As in Bermuda grass, for instance. Anybody ever try to get Bermuda grass out of your vegetable gardens or your flower beds? Anybody successful at it? I want to shake your hand. Job security. How do we know, even with difficult to control weeds like Bermuda grass? What's the one thing that we can focus on with our management if it's already germinated and we can't get it when it's young? The answer to that is periods of active growth. Target your management when the weed is utilizing its own resources for something. If you interfere with that process, It enhances your ability to cause injury to that weed, maximizes your efforts, and is the definition of work smarter, not harder. However, how do we know which one of these that we're dealing with? How do we know what category the weed we're dealing with falls under in all three of these categories? Identification is key. We just touched on that with Dr. Lujan. I guarantee you Dr. King's going to touch on that tomorrow. When it comes to pests, accurate identification is the most important thing prior to like any type of management that you try to implement. And one resource I actually have with me, if you're looking for an identification tool with plants, is a very recently updated version of the Troublesome and Noxious Weeds of New Mexico. I do have multiple copies of these booklets with me. Unfortunately, due to exorbitant printing costs, I am selling them, unfortunately. They are $10 a piece or 2 for $20. I have been told that they are very great resources, and I do have to accept cash. Unfortunately, I've left my ATM at home, but I do have some change. So if you want a copy after we get done with our events here, right after I speak, feel free to come up here. I'm at the front. I have copies, and I'll be around tomorrow if you need to get cash overnight. This is a great resource, and if you need to thumb through it before you purchase, perfectly fine. Moving on, identification. How do we utilize identification in order to target our management? How do we be successful? Your success is going to increase exponentially when you utilize integrated pest management. We heard that referred to earlier as integrated disease management. Here, we're going to talk about it as integrated weed management. You've probably heard that acronym before, right? IPM. What does that actually mean? What is IPM? How do we utilize it? The thing to understand about this really pest control, but especially with weeds, is that there's a lot of management strategies out there, right? There's a lot of tools out there at our disposal. The thing to understand is that there are, is that there are multiple options available, but no single management option utilized by itself will actively and effectively control the weed in a sustainable way. You might be able to address the weed populations that you're dealing with, but what happens if you don't switch your management around? Other weeds come in that don't respond well to that management. We call that a population shift. As a result, we utilize integrated pest management, which is the utilization of as many management practices together against the weed for effective control, keeping the weed confused, causing as much injury as possible. And maybe that should start with prevention. How effective is prevention at weed management? Pretty good, right? Especially if you're dealing with a weed like pigweed, for instance, that produces over 600,000 seed in one summer. This is where people start to have an existential crisis when I get up and speak. But this is important information we need to know, right? What happens if we have escapes from prevention? We can utilize mechanical controls, the use of tools. One of the things I get asked about frequently is, what is the most effective method of organic weed control? Anybody know the answer? Your hands, pull them. Have not developed a resistance to them yet. If you have escapes from mechanical, then maybe you can utilize cultural practices with your desirable plants. The irrigation, the fertilization, the pruning, all the things that you do to make your desirable plant, whatever it is, healthy. Maybe in this case, it's your trees and your shrubs. We just talked about that. The healthier the plant, the more it's able to withstand impacts from invading pests, and weeds are no exception. And if we have escapes from that, then maybe we can utilize the big guns for the big weeds, herbicides. Most people think that integrated pest management is management in the absence of chemicals. In reality, integrated pest management really is management with herbicides as a last resort. Save the big guns for the big weeds, especially because due to resistance, we may not have them available for that much longer. And all of that has to be utilized based on the weed biology and based on the timing that we just talked about. Strategies should absolutely be specific to the target weed, as well as accurate identification, and for the weed biology, as I've been talking about this whole time. So when we talk about weeds and where they fall under in their life cycles as far as annuals and perennials go, what does that actually mean? Based on where they fall in the life cycle, there may actually be periods of optimum control, or where we as managers have to be more focused on whether or not they are germinating from seed or they are actively growing if they have already germinated. One example of that is winter annuals. When are they germinating? In the winter. So why in the world is September through November the optimum window? Because we can get them when they're young. They're germinating from seed. At that point, the temperatures are ideal for the germination of those seeds, but also if it's already germinated, what's the major plant doing? Actively growing. This is the timing during the winter to focus on. This is kind of a general rule of thumb, of course, because this is always going to be dependent on temperature, moisture, and sunlight. If that changes up, pay attention to what the weeds are doing. Target the weeds when they're young. Should I apply a herbicide to a winter annual weed in the spring? With every extension question answered, the extension answer must start with, that depends. Because in this case, it does. Did it germinate in the fall during this optimum window of opportunity? If it did, should I apply a herbicide? Probably not. Why? Because it is way too mature, and most likely it has already done what? Dropped its seed. You've missed your window of opportunity. Mother Nature is about to take care of the plant for you. But what if it germinated during the ideal growth window during the spring, along with some of the other summer annual weeds or spring annual weeds? Maybe you then can capture it when it is young, and a herbicide might be useful in that situation. Can everybody see that? What about biennials? How do we control biennials? Get the weeds when they're young. How long do biennials live? 2 years. So they grow as a basal rosette in the first year. Great for us, right? So we have a whole year to control biennials. So we don't have any problem with biennial weeds, right? Wrong. Always, right? The more mature the biennial weeds get, the more difficult they are to control because all they're doing is producing a deep taproot in the first year. That taproot has to survive from the winter. When it comes around the following spring, that taproot then produces leaves and also bolts, meaning that it shoots up a stem and it has flowers on the top, like say your thistles, for instance, like musk or bull thistle. Once a plant bolts, that is an indication of maturity. And usually that's an indication that a herbicide application is no longer going to be effective. Perennials. Why in the world is fall the best timing to control a perennial? Dandelions, Bermuda grass, field bindweed, they're all problems in the spring and the summer, right? But what are they doing in the fall? They're actively growing, and their active growth is focusing on what? The roots. If it's a perennial weed, what are we trying to kill? The roots. I've actually conducted some research in my time as a landscape manager and focusing on weeds and looking at fall management. I just did a research project in controlling field bindweed and plantain and alfalfa, and we found that increases in injury of the herbicide to the weed, I mean, they can increase as much as 80% just by applying it in the fall, as opposed to the spring. What's the second best timing? In the spring, because what's happening in the spring? It's still actively growing. It's having to produce leaves, right? Hopefully it looks as ridiculous as I do right now. But what happens if it can't produce leaves? It has to keep using up all of the underground resources, the root system. Eventually, it will exhaust itself. Target all management practices during active growth. Can't stress that enough. Diagnosing weed problems. Why are the weeds there? One of the things that I really try to touch on in my presentations is something called indicator weeds. And what indicator weeds mean is that the presence of the weed themselves is often an indication of something within that environment that is favoring the development of the weed over our desirable plants. That could be, too high pH soils, not enough nutrients, management issues like water problems, stress, heat. All these things can factor the development of our weeds. As managers, what's the first thing we need to do if that's the case? We need to adjust the management, right? Now, if we change the amount of water that we put on our desirable plants like trees, is that going to kill all of the weeds that are there? Absolutely not. But it can give your desirable plants more of a competitive edge. So a really good example of that, anybody know what that is? Nutsedge. Some people call it nut grass. That's absolutely true. But what's going on in this situation that allows the nut sedge to outcompete the Bermuda grass in this one area? It's a drainage issue. Every time they irrigate this area, and I can tell you by experience, it's a lot, the water does not drain. The soils are saturated. There's no air that is required for the root systems of Bermuda grass. But what loves saturated soils? Nut sedge. Usually if you have a high concentration of nut sedge in one area, that's an indication that you probably have a drainage issue. So as managers, what do? Spray it, fix the drainage, and then we can spray it. What about in this situation? This is a little bit harder to see. This is white clover. What does white clover do that other plants can't? Fixes nitrogen. So if you have a high concentration of white clover in an area like a sports field where you probably want turf or maybe some other landscape plants like shrubs or trees present, what's that an indication that we need to do first off? We need to fertilize, and most likely with nitrogen. So can everybody see how that kind of works? There are a lot of indicator weeds out there. If you have a problem with crabgrass, that's an indication that you're mowing your lawn too low and too infrequently. You're stressing the lawn every time you mow. If you have a problem with puncture vine or spurge, for instance, you probably have limited nutrients in your soil, trash soils, as we call it. There's always a situation where weeds can tell you exactly what's going on with your environment. Can trees and shrubs be weeds? Absolutely, right? What about this guy? Salt cedar. Some of these trees, sort of skirt into that gray area of being slightly desirable. What about salt cedar? Never, right? Some people say it's desirable. It is good for pollinators, although I've been told it produces trash honey. But for the most part, salt cedar really falls under that weedy category, right? In contrast, some of the other, what we consider to be weedy trees, might actually skirt that gray area. In fact, I have seen all three of these for sale in nurseries around New Mexico. I'm here to tell you, please don't plant them. This is one of my favorite pictures that I've taken, is a Siberian elm literally growing out of the sidewalk in the center of Taos, New Mexico. And there were other ones too. Russian olive, gorgeous tree, beautiful tree. Smells great at certain times during the year. It's tree of heaven or tree of, right? I didn't say that. But why are these considered weedy trees? They're invasive. They're pushing out our native species. Some of them are actually draining our water resources, just like salt cedar does. Is it just as easy as just cutting them down and getting rid of them? Absolutely not. We'll talk about that. How do you control unwanted shrubs and trees? Let's talk about salt cedar for an example. You can utilize biological control, probably one of the cuter aspects of weed management. Is that going to be effective against salt cedar? That it can injure it, certainly. These are all tools in our tool belt. We can cut them down, we can grub them. If you want to take out your stresses and your aggressors, get your fire out there and just start burning things down. Hopefully you make that noise too. Salt cedar leaf beetles, the poster childs for biological control. They do a great job, but what aren't they doing? Killing the tree, but they are injuring it, absolutely. And then, of course, you can actually go out and utilize a herbicide application. Herbicides is a last resort. But are herbicides, even our big guns, going to be effective against a tree with a 30-foot deep root system like salt cedar? Likely, with one application, you're probably going to get recovery and regrowth, even though if you look at those leaves, they look like pipe cleaners on Christmas trees from the 50s, right? I wasn't alive in the 50s. I've heard the urban legends. I assume that's what they look like. But obviously, we're probably going to have to utilize multiple applications. But what are we still going to have to focus on, even though it's a tree? Timing, right? There is an appropriate timing to take care of these plants. What happens if you want to control unwanted shrubs and trees with a primary trunk, like Russian olive or Siberian elm or tree of heaven? You could just cut them down or girdle them, basically cutting down right into the heartwood to cut out the cambium tissue. The international highway for water and nutrients from the roots all the way to the leaves and then back again. That's going to affect what? Everything above that cut. What happens to what happens to the below area? It suckers right back out, right? So what do we usually have to pair this cut? Oh dear. What do we usually have to pair this cut with? a very localized, literally painted on herbicide application, minimizing your inputs as much as possible. You don't even have to make as large a cut as we have here. You can literally go through with a chainsaw, and as long as you can get that herbicide into that cambium tissue, the likelihood of it taking it down to the root system is higher. Now, what's the window of opportunity to be able to be successful with this method after the cut? About 10 to 15 minutes. So it is usually effective to have somebody cutting and somebody spraying. Even if you're just cutting down the tree, look, the localized application is even on the surface of the tree right here on the stump. All you have to do is contact the cambium tissue. Why don't we just paint the whole tree? Make it prettier. Yeah, it's a waste. That's a heartwood. It's not going to take any of the herbicide down. Now, what happens if you're out there by yourself and all you have is an axe and some herbicide? You can utilize the hack and squirt method, something I hate saying out loud. And I would probably not recommend doing that because if you're like me and you're clumsy, this is a good way to take out your leg. But it is an effective method to actually cut down into that tissue, get through the cambium, and actually make an application pretty immediately right after that cut. So these are just options at our disposal. They, of course, are not the only methods of management out there. But moving on to questions that I get about herbicides quite frequently. And I get a lot of questions about these, right? What do we know about herbicides? Would everybody kind of agree that the term herbicide or chemical has a little bit of a stigma attached to it nowadays? Probably, right? Not probably. Yes. Things to consider with herbicides. Anything that you put on a plant to cause injury or kill it is a herbicide. And that actually includes our organic herbicide options as well. And we have to think of them in that way in order to make safe and successful applications the same way as we would our traditional synthetics. And I'll talk about that more tomorrow when I have my organic talk. Regardless of all the management that we talked about, the options that are out there, herbicides are still the primary utilized method of weed control. There's reasons for that. It's relatively inexpensive. It's less labor to go out and spray something than it is to bend over and pull up an entire yard of weeds that have germinated over the weekend. You usually get a greater flexibility in timing of the weed control. Sometimes you can make an application and there's an extended period of control where you don't have to apply it. Results are often quick. I don't know about you guys, but when I spray a weed, I want to see it melt before my eyes. Very satisfying. And they can offer, like I said, extended control. But there's also caveats to that, and we'll talk about that, especially when we talk about the health of our nearby desirable plants, like trees. Herbicides are a helpful tool, just like everything else I've been talking about. By itself, they will not provide effective weed control in a sustainable way. You always have those population shifts come in, just like with other practices, but what's the other problem with herbicides? Resistance. And resistance is pretty much the number one factor that we're looking for as far as weed management in the future. What do we do when we eventually use the tools at our disposal? It's coming. Success with herbicides is always going to be dependent on, of course, accurate identification of not only the weed, but the desirable plant too, because you don't want to what? Kill your trees, right? Or your neighbor's tree. Applications in accordance with the label. We talked about that earlier. Read the label. The label is the law. Cannot stress that enough. If I could tattoo it on my forehead, I would. My mother wouldn't be happy, but I might be able to get the message home of just how important the label is to follow with management. Considerations of other desirable plants in your area, of course, trees and shrubs. But what about greenhouses? Anybody ever make applications in and around someone's greenhouse? Those fans can bring those herbicides right into the greenhouse and kill all those plants. Some herbicides have the potential to cause damage to susceptible plants. We know this. It occurs when the active ingredient moves off-site, like in the case of drift. We'll talk about that on the next slides. What about volatilization? What's volatilization? It doesn't mean they have anger management issues. It means that if they get hot, they what? Evaporate. They vaporize as a gas. When they do that into the air, what happens when the wind blows? Moves off-site, hits your neighbor's trees, and that's how you end up on Judge Judy. Leaching. What is leaching? Movement through water, either through the soil or on the surface runoff. How do we avoid all of this? Read the label, 100%. Herbicide drift is the physical movement of herbicide particles. Sometimes when you make an application, even the little bottles that you get at your local garden center, what happens? You get little particulates in the air. If you can smell the application you're making, it means there's something in the air that might actually move off-site. That's probably not good for your health either. There's physical spray particle drift. We talked about vapor drift. Herbicide contaminated soils. Some of that extended control can last long enough to where if you get compost from your local resource here, maybe in Albuquerque, maybe you can actually introduce an active herbicide into your vegetable garden. What happens when you plant your tomatoes? They come up looking very sickly, like they were in a Tim Burton film or something, if they come up at all. What causes drift? High winds, low humidity, high temperatures. What does that mean for New Mexico? It means we win, right? Fortunately. Also, increased spray height. It really does matter how high you hold that boom or that little spray nozzle off of the surface of the ground. How do you avoid drift? Learn to be a good neighbor. State Farm is not necessarily always there. Leave a buffer zone. Some labels will be very specific. Like in the case of, say, Diaron, for instance, there's a very specific statement in the label that says stay 250 feet away from the nearest tree trunk. And why is that? Leave a buffer zone. When you have to worry about windy conditions, it might be that you have to stay a certain amount of space away from the nearest susceptible plant, like a tree, for instance, or a pecan orchard, if you're in an agronomic application. If you can avoid the use of volatile formulations around highly sensitive plants and in situations where they can very easily evaporate as a gas, use another active ingredient if you can. There's more out there to choose from. Do not apply herbicides when the wind is blowing towards sensitive plants. Try to aim for the special area of wind speeds between 2 and 10 miles an hour. How often does that happen in New Mexico? In my dreams, often. In reality, probably not. But try to aim for them if you can. Spray when the temperatures are below label restrictions, especially for volatile chemicals like 2,4-D and dicamba. But even if they're not volatile, if you have particulates in the air and it's hot, it is likely that your desirable plants are stressed. And if you do have a minimum amount of drift damage, you can increase the injury that it causes. Use wide angle nozzles, reduce spray particles, get those droplets as big as possible so they are less likely to be in the air for an extended period of time. Use lower application speeds. I know, guys, the Super Bowl is this weekend and you got to go out and make your fertilizer application or your herbicide application in between halftime. You've got 30 minutes to go spray your backyard. Probably not conducive to good coverage or minimizing drift. Slow down. It actually is good for minimizing the likelihood of causing injury. You can use shielded booms to prevent movement. And also, read the label. Sorry for the people in the middle. You just get the brunt of pointing. What happens if you accidentally do have drift and you do have trees and shrubs that have been exposed to a herbicide application? I get this question all the time. I have herbicide injury. What do I do? Unfortunately, just like you'll see as a pattern with all of our pest reactions to trees, for the most part, there's not a lot you can do. Some people ask me if they can prune off the affected limbs. If the affected limbs are very localized, maybe, but what does pruning do to the tree? Stresses it. The more you stress the tree, the more likely those symptoms are going to actually stay for longer, and the less likely the tree is going to survive. So if you do have exposure to herbicides, we usually say anything you can do to maintain the health and the growth of the tree to eventually come out of it, that's about all you can do. It's the same principle if I take an aspirin and then I go to the movies later. When I come back from the movies, I don't want that aspirin in my body anymore, so I just cut my right arm off. Left arm off. Okay. Is that going to help? Probably not, because what? The aspirin is all in my body, isn't it? Same with trees. So in many cases, pruning is not going to stop any additional injury that might occur. Just wait and see if it survives. And I actually have pictures of this. Hang on just a second. I get a lot of questions on weed and feeds. Has anybody ever applied weed and feeds or been asked about weed and feeds? They are herbicides that are combined together with fertilizers. In many cases, a pre-emergent or a post-emergence, very rarely both. More bang for your buck, right? combination product, you can save money and save time. How often do we know that to be true when it comes to tree, shrub, landscape management? In reality, I really very rarely recommend, or actually really don't recommend, utilizing weed and feeds. The reason being is that there's not a whole lot of either one of the product in the bag, but there sure is enough to injure your tree if you don't pay attention to the label. The other thing is that when you're making the application, almost in every case, you're utilizing a good timing for one and a bad timing for the other. You're going to waste one. So think about it in terms right now. Would I apply a weed and feed right now for weeds? Probably, because what's happening? Temperatures are starting to go up, but what hasn't come out of dormancy yet? Bermuda grass. So if I make a weed and feed application, good for the herbicide, bad for the fertilizer. Fertilizer moves off site, may cause damage. So if I wait for the Bermuda grass to come out of dormancy, what happens to the weeds? They get more mature. In many cases, they probably won't respond well to that herbicide application, and you've put something in the environment that's not going to be effective. So it really is more bang for your buck to get a fertilizer and a herbicide and apply them at the timing at which is most appropriate for either one. Does that make sense? Some of these options are volatile and potentially can leach in the soil, like 2,4-D or dicamba, for instance, especially when you're making applications when the temperatures are increasing. We don't really have that gradual increase in temperatures like they do in other parts of this, United States. Usually we go from about 30 degrees to 90 in a week. Maybe not that extreme, but it feels like it sometimes. Read the label. So here's a couple of examples of weed and feeds that you might see. These look pretty similar, don't they? We know they're different because of the fertilizer aspects, but how do we know which bag contains what kind of weed or herbicide? Read the label. The label will say, this one on the left here actually contains 2,4-D and dicamba. What does that mean for its ability to volatilize? And even if it's available as a granule, can it still volatilize? You betcha. Sorry, I'm watching Fargo. My bad. They also have the potential to actually leach to the soil, like in the case of dicamba. The roots can actually take up the dicamba, and that's where I see a lot of injury to our trees as a result of weed and feed applications. Even when we're making applications of weed and feeds with pre-emergent herbicides, can that still negatively impact our desirable plants? Sure, if they're trying to develop new spring roots through those active barriers. Even in the case of trees and shrubs, they can actually impede the development of healthy roots, and we don't want that, do we? There's herbicide selectivity that we have to consider, such as non-selective herbicides. What are non-selective herbicides? They have no opinion. They have no preference. If you spray it on a grass, if you spray it on a broadleaf, or in conjecture, it will kill both. Just like everybody's favorite glyphosate, but also organic herbicides as well. When you have the options between acids and oils don't have the ability to choose between pigweeds and your shrubs that you just planted, right? There are selective herbicides. Now, there's a little bit of a misnomer sometimes when we talk about a selective herbicide. So here we have herbicides that won't harm grasses, like 2,4-D. But what also might be present within the vicinity of making the application? Other broadleaves like trees and shrubs. Our herbicides really fall under one category. They will either injure broadleaves or they will injure grasses. So we do have a category down here that they won't harm broadleaves like fluazephat P-butyl or cefoxidime, very common active ingredients you can find at your local garden center. If they're invading into your area and your landscape with a lot of shrubs, then it's likely if you apply in accordance with the label, you won't cause injury to your shrubs. There's also selective herbicides. So we have quinclorac and triclopyr that actually injures both grasses and broadleaves selectively. So some grasses it won't, some broadleaves it won't. How do you know which ones? Read the label. How do you know which plants to avoid? Read the label. It's y'all's turn. Read the label, right? So even when they have dual selectivity, they usually fall more under one category than the others. Triclopyr, for instance, is primarily a broadleaf specific herbicide. Same with quinclorac, but they do have the ability to injure some grasses and can be utilized as such. Quinclorac, for example, is probably the main active ingredient suggested for crabgrass control. Like I said, how do we know? Read the label. I get a lot of questions on herbicide residual activity. How long is a herbicide going to last when I make an application? And how important is that when we consider our surrounding vegetation like trees and shrubs? Sometimes it's very important. It may be that you make an application that's not even remotely surrounding them, but as they move, and if they persist for long periods of time, they can eventually come into contact with those roots. And I'll talk about that. The length of time that a herbicide can last in the soil is usually dependent on both the environment, not usually, it is dependent on the environment and the herbicide. And I'll talk specifically about those. Sometimes the residual can be short, like in the case of glyphosate. They can be really long, like in the case of Diaron. Diaron, I've seen still active 2 to 3 years after making an application in New Mexico, even though its general period of residual activity is roughly about a year. The other thing to clarify when we talk about residual activity of a herbicide is there's 2 categories that we need to think about: how long the herbicide lasts and how long it is active as a herbicide. So the really good example of that would be glyphosate. Glyphosate has no residual activity as a herbicide. If it comes into contact with a soil particle, it cannot cause any more injury to your neighboring plants, even if you transplant a plant or seed it right after you make the application. And I'll explain why on the next section. But how long it's detected in the soil is actually a little bit more extended. It's still kind of on the short scale, anywhere from 30 to 60 days, depending on its half-life. So how do we know all of this information? Read the label. So one of the things that we need to look at on the label for this particular information is something in your safety data sheet or your material safety data sheet, SDS or MSDS, I don't know why they switched it. And that is something called the KOC factor. The KOC factor is an indication as to how likely that herbicide is going to be adsorbed, because it's on the surface, bound to a soil particle. The higher the KOC factor, the more likely that herbicide is going to be very tightly attached to a soil particle. So how does glyphosate have no residual activity even though it's still present? It has a really high KOC factor. Once it comes into contact with a soil particle, it cannot be separated until the microbes break it down. Glyphosate is biodegradable. So the higher the KOC factor, the more likely it's going to be adsorbed onto a soil surface. What does that mean for its leaching potential? Very low. Glyphosate is not likely to actually leach through the soil and come into contact with your tree roots or underground groundwater systems because of that tight attraction to a soil particle. What happens if a product has a low KOC factor? It may very well move effectively in the soils. Like I said, where do you find that information? In the MSDS sheet. And it will usually be indicated as a soil half-life. That is the indication of how long it's going to take for half of whatever it is that you applied to break down in the environment. There are some general kind of rule of thumbs of how long certain active ingredients last in our systems. Again, this is going to be highly dependent on certain factors. So when we talk about the shorter residual activity, glyphosate 2,4-D lasts about a week in our soils. Fluazephat p-butyl, sethoxidin, same, a week, maybe 2, depending on the environment. 1 to 3 months, something like dicamba. So 2,4-D and dicamba are often used interchangeably because they're very similar active ingredients and they have the same mode of action. But as you can see, there are factors that do separate them, and it's probably important to know whether you should apply one or the other, right? Oxidazone, that is a pre-emergent herbicide. So you have that extended period in the soil. Oops. 3 to 12 months. Now we're starting to get into a lot of our pre-emergent herbicides like pendimethalin, dithiopyr, isoxaben. And you have some of our longer lasting like clopyralid and Diaron. I mentioned Diaron earlier. This here says 3 to 12 months, but like I said, I've seen injury caused to trees over 3 years after the initial application. And why is that? We'll talk about that. And then you have really long active periods in the soil like bromacil. In many cases, people don't recommend the application of bromacil for that reason. Bromacil lasts a long time in the soil and has activity as a herbicide, a long period of time in the soil. So you see a lot of these products like bromacil and diaron being applied in industrial situations, but what happens to the people who live in the houses next to that industrial site? Their tree roots might actually go underneath the fence line. I know it's, difficult to believe. Persistence of herbicide activity is dependent on several factors. Usually those factors are going to depend on how much they promote soil biological activity, those microbes in the soil to break them down. So the more ideal the soil moisture, the temperature and the humidity, usually, and soil organic matter, the higher the level of biological activity. What don't we have in New Mexico? Really any of those factors I just mentioned, which is why diaron can last for longer periods of time than initially indicated on the label. Another that we do have and plenty of is photodegradation. So has everybody ever read when you're making an application of a pre-emergent herbicide like pendimethalin, for instance, that you have to incorporate it into the soil? Why is that? Pendimethalin is photodegraded. The longer you leave it on the surface, the sunlight breaks it down and the herbicide doesn't work. Trees do absorb herbicides through the tree roots. We know this to be true. And we did have a presentation on tree roots a little bit earlier after lunch. But as we know, in some cases, many people think the tree roots tend to end right at the drip line of the canopy. And we know that not to be true, right? The actual roots themselves, depending on situations, depending on compaction, depending on factors within the soil itself, in many cases, the tree roots extend much further outward and are much more shallow than people think tree roots are. What does that mean for a herbicide application? It means that if you're utilizing that canopy edge as the point of limited growth for roots, and you make a herbicide application out here, and it's root absorbed, it's likely you're still going to cause injury to that tree, right? Most people say a general rule of thumb, and when you're making a herbicide application, always aim for further away from the roots as possible. Even if there are no roots underneath, we never got in trouble by not causing injury to a tree, right? The general rule of thumb is to stay anywhere from 2, maybe even up to 3 times the distance from the canopy to the trunk, if you can't actually get down below the soil and see them. In some cases, labels will be specific, like with diaron, stay 250 to 300 feet away from the nearest tree trunk. That's just to make sure that you avoid tree roots, right? We're going to finish up with herbicides themselves and really how their activity in the plant themselves correlate with some of the injury that we might actually see on the trees. When we get submissions into the plant diagnostic clinic that are not diseases, but look like herbicide damage, what are some of the things that I look at to try to determine whether or not herbicide injury actually occurred? One of the things that we have to think about is the mode of action of a herbicide. And the mode of action is the specific point of the plant that it interferes with to cause the injury. Whether it mimics growth hormones, prevents amino acids, interferes with photosynthesis, prevents root growth, these are all factors that help to kill the weed. These are all factors that we can actually see in our desirable plants as well. So knowing what they do in the plant can actually help us when it comes to looking at active ingredients that might be the culprit when we see some of this injury. And even active ingredients that are similar and used in conjunction, like 2,4-D and dicamba, as I mentioned, they have different methods of absorption. 2,4-D is only foliar absorbed. Dicamba is both foliar and root absorbed. Different half-lives, we talked about that earlier. Different leaching, volatility potentials, usually the way they are made, whether they are amine or ester formulations. And the ability to injure off-target plants. Some plants get injured by a 2,4-D more than they do dicamba, even though they do exactly the same thing in the plant. 2,4-D and dicamba are both growth-regulating herbicides, phenoxy herbicides. And what does that mean? It means that when they are absorbed into the plant, they have to move to the location in the plant that is producing growth hormones. What happens if they don't make it to that location? Nothing. You get no injury. This is why herbicide applications, when the plant is actively growing, is important because that's going to ensure that the herbicide actually gets to where it needs to get in the plant to cause injury. And so here it's made it to the point that's producing growth hormones. You have some cells that are growing normally and some cells that are not because they're taking in dicamba or 2,4-D, thinking it's a growth hormone, but it's not. And that is how we get a very distinct type of injury that we'll talk about in a moment. Some herbicides inhibit amino acids. What does that mean? Amino acids are energy for the cell. What happens if the plant cell doesn't get injury or doesn't get energy? It starves. In some cases, that can be very quick or it can take a long period of time. The ALS inhibiting herbicides, amino acid synthesis or branched, they inhibit amino acids. I got tongue-tied. Like active ingredients, halosulfuron and imazapyr. What's interesting about ALS is that when I mention herbicide resistance, what's the number one herbicide everybody thinks about? Glyphosate, right? And rightfully so, it's catching up. But when you talk about instances of resistance in plants, number one is the ALS inhibitors. Last time I gave a resistance talk, which was last week, glyphosate was roughly about 58. The ALS herbicides was at about 225 just for the top 15 active ingredients. And why is that? Because there are about 60 different active ingredients that inhibit those specific amino acids. They are ALS inhibitors. In contrast, glyphosate, even though it inhibits amino acids or an amino acid, it is a different amino acid than the ALS inhibitors. That's important because glyphosate is the only active ingredient that inhibits that specific amino acid. So what happens if we develop resistance to glyphosate? That's one of the 26 modes of action gone forever. There are herbicides that prevent root growth, like pendimethalin. All of our pre-emergent herbicides, for instance, pendimethalin, prodiamine, dithiopyr, oryzolin, isoxaben. Oxadeazone's foliar absorbed. Sorry. They inhibit root cell division. What happens if you're a newly germinating plant and you go through that pre-emergent herbicide barrier and your roots can't grow? Plant dies really quickly. But that can also mimic injury in our desirable plants as well. Some of them inhibit photosynthesis. What's a very effective way to kill a plant off pretty quickly? Limit its photosynthesis. Some of these limit the pathway that sugars and amino acids and energy take to actually feed the cells in the plant. That can take longer. Some of these herbicides actually interfere with the process of photosynthesis altogether. We're not going to get specific into those. So how does knowing the mode of action and what these herbicides do in the plant actually help us when it comes to looking at herbicide injury in trees? Your neighbor approaches you and says, hey, I saw you spraying the other day, even though it was water, and you injured my tree. How do we know? Let's take a look at what the injury actually looks like and how it correlates with the mode of action. So here we have phenoxy herbicides with a very specific type of injury called epinasty. And epinasty is that bending and that twisting, the abnormal growth, the cupping of the outer edge of the leaves in the cases of trees. The reason for that is that you have some cells growing normally and you have some cells that aren't. And that's where you get this bending, twisty Tim Burton look. Man, I'm really big on Tim Burton today. I don't know why. But this is very distinctive and usually can be utilized to identify herbicide damage, even though there might be some other stressors involved. Sometimes the phenoxy damage might be a little bit more involved than just on the surface level, like we saw on the previous slide. What likely happened in this scenario? Was it drift or was the herbicide taken up by the roots? Probably the roots, because obviously there's active herbicide that's present within this plant here that's causing this bud break of the leaves to be highly irregular in its growth. You get this sea anemone look, right? This is actually a pecan tree, believe it or not. And what's interesting about this is it goes back to what I was saying, that in some cases it is worth it to actually wait and see if the plant grows out of the injury. The reason being is does this look like this tree is toast? It does, but it did actually recover. And to this day, it is still producing pecans on campus at New Mexico State University. So sometimes it is worth it to wait, even though it looks pretty dire, because those limbs are still alive. Sometimes this injury can be localized. This especially helps us to negate out maybe the possibility of diseases or other abiotic factors like drought or heat. Because what happened in this scenario? What happened when they made the herbicide application to the gravel and maybe even to the sidewalk to get weeds that were in the cracks? What gets hot? Gravel and concrete. What is 2,4-D and dicamba? A volatile herbicide. And as it evaporated as a gas, it came into contact with this side of the tree. And I actually have been following the progress of this tree since I started in 2015, and every single year, this side of the tree recovers a little bit more. This used to be actually much more noticeable than it is now. In fact, you can kind of barely see the injury now, but I've been there almost 9 years, so it might take a while is what I'm saying. But anytime you see injury to one side of a tree, often that's an indication that something else is going on, probably some sort of pesticide injury. What does glyphosate injury look like? Glyphosate blocks amino acids. Amino acids are what? Energy for the cell. So what's the first thing that's going to happen? It's going to wilt. That is not a dance move. It's going to wilt. The next thing that's going to happen is it's going to be chlorotic, turn yellow and eventually brown and look dried out and starved. What's really interesting about the way the chlorosis shows up in glyphosate is how it looks in comparison to other injury, like, say, iron deficiency. Iron deficiency, we mentioned earlier, is intervenal chlorosis, which means the area in between the veins is yellow and the veins themselves are pretty green. So in the early stages of glyphosate damage, it actually is difficult to tell the difference between the two. And as that plant actually regrows from the glyphosate, you still have cells that are kind of interfered with, not being able to produce energy for themselves. So you get this elongated and this strapped look to the growth, as you see in this photograph here. Now, what happened in this instance? This wasn't volatilization, it was what? Drift. Made applications right underneath this tree over concrete, gravel areas, and then what happened to the particulates? Went right up into the contact, the leaves of the tree. Now, is this going to kill the tree? Doesn't look like it. It will eventually grow out of it, and it did. But it's not very pretty, is it? We don't want this on our trees. But you can see that kind of elongated and strapped growth as those leaves just try to grow normally, but they just can't. What happens when you have photosystem 2 inhibition? It inhibits the pathway that the energy and the sugars take from photosynthesis to actually get to areas that they need to produce energy for the plant. It's a longer process. Sorry, it's a shorter process, pardon me. What's interesting about this injury and very classic diuron damage that I have seen multiple times in the plant diagnostic clinic is that we don't have intervenal chlorosis, we have venal chlorosis. The veins themselves are actually yellow in color while the plant's leaf surface in between is green. And in many cases, this injury is going to show up on newer growth. Why is that? If it inhibits photosynthesis, what is newer growth doing as opposed to older growth? Photosynthesizing, growing. So you're probably going to see this injury at the top part of the tree first, more so than the bottom. In contrast, we have injury in the form of blocking those other amino acids in the form of the ALS herbicides, like imazapyr. This usually is going to take a little bit of time in order to develop those injuries because amino acids are basically the last stage in providing energy for the cell. That's why glyphosate takes up to 14 days in order to show injury. There's sometimes these take time to work in the plant. But you start to see this abnormal growth, this strapped, this beaten appearance. Sometimes you might see thicker leaves. In salt cedar, this is where you get the pipe cleaner from the 50s look. These are abnormally growing leaves. One of the things I did want to point out there is a mode of action called carotenoid herbicide or biosynthesis inhibitors. Basically, they are bleaching herbicides. The reason I wanted to include that is that there is no abiotic disease or insect symptoms that mimic bleaching in a plant. If your plant turns white, it's a herbicide damage. And specifically a herbicide that destroys the protective pigments that prevent chlorophyll from breaking down in the sunlight. It's really complicated. The chlorophyll is exposed to the sunlight. Ironically, it breaks down. And that's where you get the bleaching appearance. And if it's not green and it's not photosynthesizing, what happens to the plant? It starves. Root inhibiting herbicides. How do our pre-emergent herbicides prevent germinating plants from growing successfully? As those roots try to pass through that barrier, they can't grow anymore. And in a young plant, that destroys them pretty quickly. Then in our desirable plants, if you plant into an area that has active pre-emergent herbicide, say with grass or even our shrubs, trees, you might be able to plant a little bit deeper in that process, depends on how much you incorporate the pre-emergent herbicide, but I have seen tree roots injured by pre-emergent herbicide active areas. How do I know? The injury is very distinctive in what we called clubbed root ends, this swollen growth at the end of the roots, and also highly stunted root growth. You can see those clubbed ends right there. That root tip is trying to get through that barrier and it just can't. You have abnormal growth. Now, very rarely is this going to kill. This is a corn plant. This is probably not going to kill the corn plant, in contrast to a healthy germinating root system that didn't have pre-emergent herbicide. But what happens when it gets hot, when it gets dry, when we have stress? This one's going to be toast a lot more quicker than that one is. And same with our shrubs too. Important things to consider when talking about herbicides especially. Choose a herbicide based on the type of weed that you have, identification. Always take into consideration your surroundings when making these applications. We've been talking about that. Always read the label. If you don't wake up at 3 a.m. and go, read the label, I've failed in my endeavor today. Hopefully I gave you nightmares. Utilize methods and strategies to minimize off-target damage to desirable plants through volatilization, leaching, soil residual activity. We talked about a number of things. And if you do have injury to a desirable plant that semi-resembles herbicides, take a look at what's been applied, because if you make an application, you should keep records. See what's been applied. See if you can correlate that mode of action to the injury that you see. That's basically what I do for the plant diagnostic clinic. And with that, moral of the story, get the plants when they're young, before they have their gun license. And I'm from Texas, I can make that joke. Thank you. And if you'd like to purchase a book, I do have my box down here. So when we're finished today, come buy books. Yes, sir. Sure. I've been asked to go back to the pecan tree picture for a moment. Yes, sir. Great question. So the question is, in many cases, this type of injury can mimic other types of abiotic stressors like heat stress, drought stress, trying to bud out after a particularly cold winter. There's a lot of things that our trees can do. How do we tell the difference between them? Sometimes I can look at the injury and try to see, but in many cases, this also mimics a symptom that we're seeing very frequently around the state called witch's broom, which may also be in response to a lot of abiotic stressors. In that case, I would ask about the history of what's been applied in that area, when it was applied, how it was applied, and then maybe I can take a look at the injury there and see if that correlates with what I see. Unfortunately, herbicide diagnosis at the plant diagnostic clinic, we can't do testing to test for herbicide residues. So in some cases, I have to respond with, it may be herbicide damage, but I can't say that 100%. Really good question. I've rendered them speechless. Or you want to go to dinner. Any other questions? Thank you, guys. Yes, I remembered it too. Yeah, thank you, sir. Oh, we do have a question.
One question from online. Great presentation, comment, and also, do you have a link or place where we can purchase your noxious weed book online?
Great question. So I know we're on a microphone, but if you want to actually access the booklet online, you can access it by a PDF through the NMSU website. You can just Google the title and the PDF version of it, although I have heard unanimously that people prefer the actual booklet if you can get a hold of it, because one side has pictures, one side has information, and it's easy to flip through. But you can print the PDF version, absolutely, and it is open access and free.
Thank you.
Thank you, guys. Thank you.